Hello everybody, this is Mr. Shaban. Today we're going to complete our chemistry unit, which is discussing the reactions. We have discussed the exothermic reactions earlier, and we said exothermic reaction is the reaction that produces energy or gives out energy. Right now in today's lesson we're going to discuss the endothermic process. So we're going to look at the endothermic process. By the end of the lesson, you are supposed to know the following: that the endothermic reaction is a chemical reaction in which energy is taken in, and an endothermic process is a process in which energy is taken in, for example, dissolving. During an endothermic reaction or process, the temperature decreases. The keywords of today's lessons are endothermic reactions and endothermic process. So let's start our lessons with the following chemical reaction. In this chemical reaction, we have sodium hydrogen carbonate. When you react sodium hydrogen carbonate with citric acid, it's going to produce sodium citrate along with water and carbon dioxide. The chemical reaction which is discussed right now is called an endothermic reaction, because the reaction takes an energy from the surrounding in order to be started. So in order to react these two reactants together, the sodium hydrogen carbonate along with the citric acid, they take energy from their surroundings. So you're going to feel like a drop in temperature. Unlike the exothermic reaction, you're going to have an increase in temperature. Over here in endothermic reaction, you're going to have a lower temperature because it sucks the energy from the surrounding. So during the reaction, energy is taken from the environment. This results in the content of the tube having a lower temperature, because I want you to imagine the following. If you're confused about endothermic and exothermic, please focus with me on this particular point. What happens when somebody has a fever? Normally the mom used to put something on the forehead in order to take the energy or the heat energy from the body. So when the mom places a cold surface on the forehead, after that the surface of the forehead is going to have a low temperature. This has happened because the cold item has taken the heat energy from the forehead, and this is exactly what happens in the test tube. When you place these two reactants in the test tube is going to take in, the reactants are going to take in the energy from the test tube, and you're going to feel that the test tube is cold. By the way, this reaction takes place in the sherbet or the sweets that you eat. That's why you feel like a freeze or like a cool feeling in your mouth when you eat these sweets. Right now we're going to discuss the differences between a process and a chemical reaction. For discussing an endothermic process or reaction, in both we're going to have a drop in temperature, lower temperature. In the process that takes energy from the surrounding, the reaction also is going to take energy from the surrounding. Both have lower temperature, but here we have no new substances made. In the reaction we have new substances made. So the difference between endothermic process and endothermic reaction, that process is not going to produce any new material or any new substance. You're going to have the same substance. While in the other hand, the reaction is going to produce a new substance, and that's the main difference between a word process and a word reaction. But as we discussed endothermic process and endothermic reaction, both of them are going to cause a drop in the temperature. I want you to look over here, dissolving potassium chloride in water. This is an endothermic process, but let me ask you a question. When you dissolve a potassium chloride in water, do you have a new product? Do you have a new substance? The answer for this is no, because when you dissolve a potassium chloride in water, it's like dissolving salt in water. You still can get the salt back by the help of evaporation. So you don't have any new product. No change, no chemical change has taken place. That's why we call it process. And it's an endothermic because by dissolving the potassium chloride in water, you're going to have a drop in the temperature of the beaker. You're going to feel cold. When you touch the beaker, you're going to feel that the temperature is low. It's cold. So this process takes in energy from the surrounding. I want you to look over here. This is the change between the states of matter. We have liquid, we have gas, we have solid, and you know that in order to change a solid to a liquid, we tend to melt it. If you want to change liquid to gas, we evaporate it. If you want to change solid to gas directly, we do the deposition, and the other way around, sublimation from gas to solid, and freezing from liquid to solid, and liquid from gas to liquid, we tend to condensate. Right now I want you to think about one point, and I'm going to give you a minute for that. Which process takes in energy in order to take place, and which process gives out energy in order to take place? Think about it, and I'm going to see you within a minute. Okay, let's discuss that, guys. Time is over. Let's see. In order for the process to take place by taking in energy, we're going to call it endothermic reaction. If the process is giving out energy, we're going to call it exothermic process. So liquid to gas. Let's discuss. Liquid to gas. In order to change a liquid to gas, we heat it. So heating is giving the process energy. So energy is taken in by the process. So that's an endothermic process. On the other hand, in order to change a solid to gas, we heat the solid. And some solids, they don't change into liquid, but they change directly into gas, like the dry ice. So that's an endothermic process. And from solid to liquid, in order to melt an ice, we give it energy, so that's endothermic process. While on the other hand, the process of condensation, changing gas to liquid, we have to cool down the gas in order to change it into liquid. Cooling down means that the gas is going to lose its energy. If the gas is going to lose its energy, it means that the gas is going to give out energy. When you give out an energy, that's an exothermic process. So gas gives out energy to change into liquid, so that's an exothermic process. And then we have the the liquid change into solid. Liquid need to lose the heat energy in order to cool down and change into an ice. That's why we place the water into freezer to cool down. So that's giving out energy, and this process is exothermic. And at the end, sublimation also is exothermic, where for the dry ice, when we cool down the gas of carbon dioxide, it changes directly into solid. I hope you have understood this concept, because it's very, very important to know how to differentiate between an endothermic and an exothermic process. So that's the second point of today's lesson, exothermic or endothermic. In this lesson, we are going to see how the exothermic and endothermic reaction can be identified by taking the temperature at the start and at the end of the reaction. And we're going to look for the processes as well. We're going to see how to use the exothermic and endothermic in a nice way. The keywords of today's lessons are endothermic reaction, endothermic process, exothermic reaction, and endothermic process. So I want you to see that's an exothermic reaction and that's an endothermic reaction. Just a quick recap, we know that exothermic reaction and the process both are giving out heat. So imagine that these are the reactant. These reactant are producing heat. Heat is given out, as you can see over here. So that's an exothermic. It can be a process and it can be a reaction. On the other hand, endothermic reaction and process, heat energy is taken in. So the reactant are taken in energy, and that's how you can differentiate between exothermic and endothermic. Here energy is taken in, surface is feeling cooler. Here energy is given out from the reactant, so surface is feeling hotter. Okay, let's discuss the first use for the exothermic reaction, self-heating cans. We have something called self-heating can. Self-heating can has like a chemical process that takes place inside it. And the self-heating can, you're going to find calcium oxide and you're going to find the water. Both are found in a separate parts inside the can. These are found in the not the inner one, like in between the layer of the can, you're going to find the calcium oxide and water. As it's discussed over here, you can see that's what is found between the outer surface and the food. So that's an inner layer in between the surface and the food. So this chemical reaction takes place without coming in contact with the food. But what happens when calcium oxide is mixed with water? When calcium oxide is reacting with water, it's going to change into calcium hydroxide, and this process is an exothermic. This reaction is an exothermic reaction. It produces a huge amount of heat energy, and this heat energy is going to be enough in order to heat up the food or the coffee which is found inside the can. So you can eat it without heating it by simply shaking the can. The calcium oxide is going to react with the water and producing calcium hydroxide and heat energy as well. Not only that, but also we have another application for the endothermic process is a chemical ice pack. This chemical ice pack can be used once. When you get these chemical ice pack, also they contain chemicals. These chemicals, when they react together, they are going to take in heat energy from the surroundings. So you can, as you can see, squeeze it, rub it, and then apply it on the place. So when you apply it on the place, the reaction will take place and is going to take the heat energy from your body, and this is an endothermic process. I hope you have enjoyed today's lesson. In today's lesson, we have discussed the differences between endothermic and exothermic reactions and processes, and we have taken some of the uses for the endothermic and the exothermic reaction and process. Stay safe and see you next time.